Hello and welcome. Here to talk to you today about chapter 3, relational database model. It's a big chapter, so I'm going to call this part 1, and we'll probably spend a little time on this next week as well. We have a general idea of what the relational database model is, but we're going to start to attach a few terms to it today. Starting with relation, right? Relations are what make relational database models work. We have these entities that are described by tables, and in making the connections between those entities, right, as we delineated with the lines that we made between the tables, that is the relationship. So that's what makes this a relational database model. And when we talk about those tables, here's a table from the last video, right? Very basic table, just describing a painter. And it's important to know that the way that we perceive this data is not the same way it's stored on the computer. But in terms of the way that we think about it as a two-dimensional structure. It's got rows, it's got columns, right? That's what a table means to us. Each table row describes a single entity occurrence, right? Or as I sometimes call it, an instance of a painter in this case, right? So all of the information associated with Vincent van Gogh is found on one row, and with Pierre Renoir is found on the next row. Each column represents an attribute, and each of these columns has a distinct name: first name, last name, born, died, representing the year that these artists were born and the year that they died. Again, the way the computer stores it, they don't keep track of the order of these things. It matters not at all that Vincent van Gogh is number 1 or Pierre Renoir is number 2. That's just for our purposes in terms of the computer. There is no ordering of neither rows nor columns. All of the values in a column need to conform to the same data format. So like all of these would be stored as maybe as integers, maybe as date time objects. Same here. These will be stored as strings, right? A set of characters, etc. So that needs to be uniform. You can't have in the same column, you can't have like this be a string and this be a number and this be a date time. Like that doesn't work, and it wouldn't make sense anyway. And of course, the intersection of a row and a column, right? The second row and the second column has the word Pierre, right? That is, it represents an individual data value. Finally, each table must have an attribute, sometimes combination of attributes, but generally speaking, a single attribute for our purposes that uniquely identifies each row. That's why we always start off by putting an ID. And this ID needs to be unique. So the primary key is a number, and that number belongs to one artist and one artist only, such that when we refer to that number, we know exactly which artist we are talking about. Okay, that value is the primary key. A primary key attribute or combination of attributes that uniquely identifies a row. And primary key is a subcategory of the general idea of a key. A key consists of one or more attributes that determine other attributes. So what other kinds of keys are there? Well, I'm glad you asked, and we just saw it again in the last video. It's the foreign key. In order to establish those relationships in the relational database, we can create a foreign key. And what makes it a foreign key is that those numbers match the primary keys in a different table. So if we have paintings, we've got the information that we want in terms of it painting's name and the painting's year. What if we want the information about the painter? Well, we have a column that is a foreign key. We look up the number here, and it takes us over to this table over here, and therefore all of the information about the artist, the painter, can be found from this one number, right? So foreign key, again, is an attribute that refers to a primary key from a different table. Here's another example. We got two tables. One refers to products, and product has a code. Okay, that is the identifying key or the primary key here. So it doesn't have to just be a simple integer. Description, price, blah, 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 over to vendor code. Vendor code is a foreign key. So you can look up this foreign key, and it refers to a primary key over on this table, which is the vendor table. So who's the vendor for our claw hammer? It's whichever vendor is in position 232. That is Annalise Crystal. She apparently sells us our claw hammers, and there's more information about her that we can find here. All right, some key terms that you will need to know for your homework. Determination. Determination is the state in which knowing the value of one attribute makes it possible to determine the value of another. And this isn't such a sophisticated concept, right? An example from geometry. If we know the radius of a circle, I put the little circle here so we know we're talking about circles. If we know the radius of a circle, that means we also know the area. We just got to calculate it, but we have all the information we need in order to identify it. That's called determination, okay? Here's one involving 3 variables. Well, if there's 3 unknowns, if we know 2 of them, we can solve for the third. So if we know revenue and cost, then we could identify what the profit is. Similarly, if we knew the profit and the cost, then we could know what the revenue is. 2 of the 3 will get us what we need. Functional dependence means the value of one or more of the attributes determines the value of one or more of the attributes. Here's another example, this time involving students. Here's a table, it's got students. One of the values stored for students is credits, and I just made up a thing that says credits less than 100 means the student is considered an undergrad by the university. Greater than 100 means they are a grad student. And I am far enough away from being either of those that I have no idea if those numbers are accurate. So what do we know about the relationship? Clearly there's functional dependence that's going on, right? One of these determines the other. Let's look in slightly greater detail and learn a few more terms. Okay, a determinant is a thing where a determinant is the attribute whose value determines another attribute. And the dependent is the value that is determined by the other attribute. So what does that mean? Well, it means that this value, status, can be identified if we know this, the credits, right? If I know that someone has 16 credits, I can tell you that their status is undergrad. If I know that they have 294 credits, then I can tell you that their status is grad, all right? And note, this doesn't go both ways. If I know that they're a grad, I cannot tell you how many credits they have. You know, I can tell you it's more than 100, but that's all I can tell you. So it is not a two-way street. Which one of these is the determinant? The determinant is the credits. The credits determines what the status is. So the status, therefore, is the dependent. It's this attribute is determined by the number of credit hours that each student has. All right, a few more terms that you should be familiar with. Good database design means you need to respect two types of integrity: referential integrity and entity integrity. Let's talk about each of those. And this is a really ugly slide. I almost broke it up, but I just ask you, let's focus on just the top part first. What does entity integrity mean? It means that all of your primary keys are unique, right? It would sort of defeat the purpose if we had several painters that all shared a common ID. And also, none of them can be null. Again, it would sort of defeat the purpose if we didn't bother to give a value to some of our painters. The goal is to give each row a unique identity. And if you don't have a unique number, then that sort of falls apart. So let's look at the next table and ask the question, are we respecting entity integrity? Here's a table customer. Each customer has an ID. So the question we must ask about entity integrity is, are all of these values unique? And we see, since they're listed sequentially, it's very easy to see that all of them are in fact unique, and also that none of these values are null. Null, by the way, doesn't mean zero. Zero is a legitimate value to have. It means there is no value given. So, yep, all values are given and all values are unique. That also applies to this table down here. So we can say that we have respected entity integrity. Let's talk about referential integrity. Referential integrity, now we're talking about references, and references are done through foreign keys. So referential integrity, we are talking about the way that we use foreign keys. And the rule is a foreign key must have either a null entry, as long as it is not part of its table's primary key, or an entry that matches the primary key value in a table to which it's related. So I guess it's nicely summarized in this parentheses here. Every non-null foreign key value must reference an existing primary key value. Okay, so what does that look like? Let's look at the table again. Every non-null, so it's okay if they're null. If we're talking about referential integrity, it can be null, right? So in this table, we've got customers, and customers have agents. Maybe somebody hasn't been assigned an agent yet. Is that a catastrophe? Not really. If we look up the agent code and it's empty, we can respond to that. So the question we now have to ask, yeah, there's some null values. That is okay in terms of referential integrity. But do all of these refer to a valid agent? We have 502s, 501s, and 503s are all of those values that we find on the agent table. Hey, they are. They're all there. So we either have nulls or valid values from this other table, which means that we are also respecting referential integrity. So things check out. And here we are. Here's Starry Night. That means I have covered all the slides that I need to cover. So thank you for viewing. This should help you considerably with the homework questions that have been assigned. So good luck with those. Let me know if you have questions.